Hello, hi, and I'm all set. Two sets of studies back to back, part one and part two. So stay glued to your seats. Part two is as exciting. So part one, enzymatic and so digestive enzymes. So it's a collection. So I'm looking to react only protease or peptidase, and it's a hydrolase. I had mistakenly thought it's an oxidoreductase, so it would oxidize and or reduce or the two together, the two go hand in hand. So if it's if one is being oxidized, the other is being reduced, so that sort of thing. So water is the base. Reactor volume has 30 ml of water, as with my previous studies. So this is the inorganic compound, bisulfate sodium bisulfate, and this is sodium lauryl sulfate. This is the organic. This is the inorganic, NaHSO4. So I'm hoping, and this time I have gloves. I'm hoping to either, but it's a hydrolase, so the water is going to react with these compounds with the peptidase. The other enzymes which I've read out, you know the list. A closer look. Um, the other enzymes maybe not reacting because they're mostly bio enzymes, so found in the human biochemical enzymes. So if ideally my reaction should be sodium bisulfate would be sodium hydride plus sulfur dioxide, and reacting coming out of sodium bisulfate, and with sodium lauryl sulfate, which is the organic compound, I would be getting an alkane C12H26 and sulfur dioxide, and maybe sodium hydride or sodium oxide. Even that could be a possibility. So I am going to get going, and this time safety glasses, because it's all not. Uh, oh, this is, I think, the reverse. On this, the reverse. Okay. The always safety glasses, and I will just have the exhaust in case, and also I need additional pressure to atmospheric pressure, and next time around I'll be adding pressure. How? You have to watch part two. Okay. All right, so now I'm going to add first organic, write notes for myself, uh, so I don't get confused. Organic, organic, no pinks, they say in engineering. No pinks, well, reds, Canada, in organic. So I wore the winning Raptors team for a winning reaction. This I bought when they won the NBA championship. So organic and inorganic. And I'm doing two substrate concentrations. Yesterday I had simply spectacular results, right? As you saw with my calculation, with three substrate concentrations. But my point, the hyperbola, went through only one substrate concentration. So I'm just doing two substrate concentrations this time for the enzyme studies, and for each compound. All right, so that's four. I'm juggling four. Stir, stir, stir. It's going to be stirring away. Stirring. All right, so teaspoon. So first organic, half is S1. One teaspoon is S2. So half a teaspoon. To struggle with the analytical balance, and this was a trick of taught, sort of cute to me by sources, friendly helpful sources. Half a teaspoon, and of course there's always plus or minus 95% confidence interval. So I used to struggle with our analytical balance in the lab, and you know, 1 teaspoon. I should 1 teaspoon. 1 teaspoon. Excuse me. This is all non-toxic. Soap and pool. Sodium bisulfate does sting a bit. Okay. So this is I'm going to close this time. So this is a different teaspoon. This is for this. Separate teaspoons. This is for this. And I'm going to inorganic sodium bisulfate. I'm going to use this spoon or all right. This teaspoon. Gray. Gotta crush it. Sorry. Hiccup. So, maybe mortar. That's good. So half teaspoon, 50 teaspoon for luck. White not in the winter actually, but you know. There are a few lumps, so I'm taking a little less than half teaspoon. Half a teaspoon. And I'm going to add the enzyme. This is okay, 1 teaspoon. These are big teaspoons, you know. All right, if you look at it, let's just crush this. Crush. But it's you can swallow it. Although we do swallow cool water, right? Once in a while. Two and 3 more to go. All right. So I'm going to use this to stir. So this is going to stay in here. I'm going to lock it up. We'll see how the results go. All right. So half teaspoon, 1 teaspoon. So S1, S2, two substrate concentrations. Enzyme's going to go in. And I'm going to use 2 hands and stir away. I'm going to become ambidextrous. So, but it's a little difficult, tricky, right? If people who are ambidextrous get it going well. So let's hope this is going to be put this way. And all right, acid test. Yeah, acid test. All right. So beginning with the organic. Enzyme, enzyme in, 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 and I'm not stirring, so you see. So a little bit of delay in the timing. Time delay, process control, it's a factor. Time delay, I think it's a, putting in enzyme. 2 second time delay. So control. Process variable. What is going to happen? All right. Okay. Stir, stir, stir. 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 I think 2 hands are a little hard for me. Stir, 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 stir. This was here. Stir, 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 stir. It's going to work up a lather. Sodium lauryl sulfate. Yeah, quite the lather. Stir, 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 stir. All right. What's the time now? Okay, 12 stir, 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 stir. It's actually all worked up a lather. Stir, stir. All right. So we will see. Okay, so it begins. So this is for the organic. So organic comes first. I zeroed this in. This is okay, zero. All right. So this is for 25 by 3. 25 by 3. All right. So we took this out. And next one. Twenty-five by 2. All right. So this goes here. This goes out. Roughly, 5 by 4, I think. 25 by 4. Interesting. I never got 25 by 4 all these days. Although this is a full teaspoon. It's full teaspoon. When I'm taking it out, 25 by 2. Okay. All right. So stir, stir, stir. Okay, this is done. This is done. Stir, stir, stir. What's the time now? 9 minutes. One more stir. So enzymes are very specific in function, but this is my own finding that they tend to catalyze, they tend to work. All right. 5, 5. So either measuring the reactant. Actually, 25/3. It's it. All right. 5/2. And 5/3. 5/3. Stir, stir, stir. Pure substrate solutions to stir. Six. 6. All these are more like a solution. All these react with water, right? Cool solvent, pH balance, and then sodium lauryl sulfate. So this is good. So this comes up next. 25 by 5. So I told you the trick yesterday. Product. I'll be measuring product again. Enzyme kinetics, right? 25 by 3. Yes. This is a 3/4 spoon sample itself. Oh, 25 by half, too. 25 by 2. A 3/4 sample. This is you have to remember sulfur dioxide. If the reaction has followed the stoichiometric ratio, right? Stoichiometric ratio, the kinetics, and um, specifics that I thought, I mean, that I discussed with you earlier, then it means that three, one more. That's good. So I think this is enough. This so next point, and this is this is again um, well 60% of the spoon. So it's 25 by 5, but I have only 60% of teaspoon. Always make a note, and then when you're calculating, it all falls into place. I think this is pretty much done. I'll find my 25 by 3. This is again 60%. 60%. Five, 60, 25%. And I just wait, stir away, and wait. So next, the trick. All right. So it's close the marker. We're gonna take one more measure. Last bunch measurement. 25.5. So I'm going to just look at this, see if I had the right reaction and the right calculations, and then come back on. Okay, this is good. And then 25 by 5 itself. 25 by 5. Or I will see what I can conclude. I'm going to take the other because my husband's going to come back by 6:30. It's a cricket match. Yeah, Australia versus England, right? So he's going to be back early. 25 by 3. And last point. Next. Surprise, surprise. Three. All right. Or a quick these are my points. And yesterday I did very well. So this is this is here, and this is here the 15 minute. So I did very well, and so let me just see. So half a teaspoon, 1 teaspoon, minus this, right? This product would be minus this at time 0. So 25 by 4, 25 by 3, 25 by 2, 25 by 5, 60 to 70%. That goes there. Okay. So I'm going to do part 2. How's that? All right. So I'm going to come back. So I've shown you these results and a secret pressure variable. All right, pressure variable. And I'm hoping to, study the Arrhenius theory by substituting pressure instead of temperature there. Arrhenius theory, of course, you all know, for kinetic constants and e to the power, but this is not a gaseous reaction, right? The universal gas law does not hold good. PV equals nRT crashes. So, but then entropy, the molecules are changing when the enzyme is working. Actually, enzymes lower activation energy. So, this is just a study. So if it's consistent, then, activation energy matching, then voila, it's all correct. And so entropy is related to pressure. Pressure decreases when entropy increases. So state of disorder right now had increased, pressure had decreased. All right, so this is what I'm going to do, and get back with adding pressure. Secret to it. Some artists' work, or well, I have one other one, but it's a sports theme today. But that's cannot fan a lot. Nobody who's playing sports for Toronto for to cool down during the game. All right. Signing out, Gayatri B. Sitaram. Thank you.